Hello there, Year 11 Math Methods students. It's Mr. Herman here, and this video is going to be dedicated to answering the infamous question of question 14 on the Math Methods Unit 1 assignment that I gave back during rollover. This question is a bit of a doozy, and I've had quite a few of you ask me how to approach this question during the holidays. Conveniently enough, while I'm away from my laptop because I'm enjoying my holidays, don't have to do holiday homework. But yes, it is a tricky question, and this video isn't going to show you the actual solution itself. It's going to show you the steps to get to the right solution. In fact, there's going to be quite a bit I'm going to show, and then what you're going to do towards the end of the video, or the end of the question rather, is rearrange whatever approach I've given you to try to come up with the correct solution that has been provided. So let's get straight into this. The question goes as follows: a sentry walks X paces of average length Y meters in Z minutes. His speed in kilometers per hour is, and there are 5 choices to choose from. Now what's tricky about this question is that they've got variables, yes, X, Y, and Z namely, but there are no other numbers given within this question. And then you look at the answers and there are all these there are variables involved that have X, Y's, and Z's, but there's a 6 and a 10 with powers involved. What's going on here? How do these numbers come to play? Where do they come from? And what is it that we're actually trying to implement into a fraction so it represents this? Now there's this information that has been put here seems pretty vague. So how do you tackle this question? What is it that we're exactly looking for, and what's the best approach to this? So we've got these variables. There's X paces of average length Y meters. What I'm going to do is I'm going to underline the 3 pieces of important information. Oh, there's more, but within this first sentence. So a sentry walks X paces. Okay, so a sentry walks X paces of average length Y meters. Of average length Y meters in Z minutes. His speed in kilometers per hour is 1. His speed in kilometers per hour. So there's another thing that we're also looking for, and this is the speed in kilometers per hour. Okay, the focus here is what we're trying to look for is his speed. We're trying to look for a rate of some sort, and specifically kilometers per hour. Now obviously we don't have enough information number wise to put into the speed, so there are going to be variables within the speed, but where do these other numbers come from if we're only just dealing with variables? And this has to do with the fact that what we've been given is a distance in meters and a time in minutes, but what it's specifically looking for is a speed in kilometers per hour. So there's some new numbers that we have to introduce into our maths to force this meters and minutes into kilometers and hours. So we are looking for a speed. And every time I think of speed, distance, and time, I always refer to this neat little triangle here that has distance, speed, and time. And we're trying to work out specifically what the speed is. In order to do this, we need to have information regarding the distance and regarding the time, and how we get our speed. This will be distance over time. Okay, if you've gotten this far, that is good. If you know that we're trying to look for speed and we need distance and time, that's awesome. Now you would think that, okay, cool, we're trying to get our speed, we need some variables on the top and some variables on the bottom. Why doesn't it look like just variables within our answers? Again, it has to do with the conversion of meters to kilometers and minutes to hours. So what is our distance? Here we have a sentry that walks x paces, and this pace, whatever this pace is, has an average length of y meters. So maybe one pace could be 2 meters, that's a very big step, or maybe just 1 meter, or maybe it's 0.8 meters. We don't exactly know what this length is, but we do know that a pace, okay, if we call this a pace, so a distance that a person, this specifically a sentry, takes in one step, this here is y meters. We don't know what this y is, but we do know it is a certain amount. Now, we need the distance, and so this sentry walks x paces. So the sentry walks another y meters, and then another y meters, and another y meters, and it keeps walking, obviously, until he gets to the end. So here is the end. Okay, so start and end. And we want to know, well, the distance will be the amount of y meters there are all up. And this is determined by the amount of paces that has been completed, which we know is an x amount. This sentry has done these paces x times, x amount of times. So the actual distance itself, the actual distance is the amount of each little pace, which is y meters, multiplied by how many times this has been done, x. So my distance is y times x meters, or x times y meters. X times y meters. Commutative, so it makes no difference because we're dealing with multiplication. So it's x times y meters. But we don't exactly want this distance to be given to us as meters. So it would be cool if the sentry walked maybe 1 meter was the average pace, and did this 20 times, and obviously the distance would be 20 times 1, which is 20 meters. But we want this distance to be given to us in kilometers, because we're trying to look for the speed in kilometers per hour. So we have to remember our rules regarding how many meters there are in a kilometer, or how many kilometers rather there are in a meter. We know that 1 meter is also equal to 0.001 kilometers. This here is the same thing. If you can tell me how many meters you have gone, I can convert this because I know there is 0.001 kilometers within a meter. So to get from meters to kilometers, we need to divide this by 1000, or we can multiply this. We can multiply this by 10 to the power of -3, which is the scientific notation looking approach. And this is where you see that 10 to the power of something, and you can see it popped in with the solutions here. So you know, yep, okay, we're on the right track. We've got a 6 here. Where's the 6 coming from? We'll deal with that later. For now, we know that the distance is x times y times 10 to the power of -3 kilometers. Okay, so we've done a conversion. We've gone straight from meters to kilometers, and how we did this is by manipulating this, by multiplying it by 10 to the power of -3. It still will represent the same thing in the distance. This one is going to be shown in meters, which is this one here namely, and one's going to be shown in kilometers, which is what we want because we're trying to look for our speed based on kilometers per hour. Okay, so now we've got our distance. Cool. We're going to whack that distance into the formula of speed is equal to distance divided by time, but we need to get what our time is. Now time is simpler because it's only dealing with one variable. So time here, this is given as one variable as z minutes. So time is equal to z minutes. But again, we don't want minutes, we want this in the form of an hour. So how we do this is whatever minutes we have, we can just divide this by 60 because there are 60 minutes within an hour. So for instance, if this century took 120 minutes to walk, all you would need to do is 120 divided by 60 to get 2 hours. If it was 60 minutes, it would just take 1 hour. If it was 90 minutes, it would be an hour and a half. So whatever amount you have in minutes, you would just divide that by 60. If it's less than 60, you would just then get a fraction form of that out of 60, and it would be that amount divided by 60 as an hour. So your time in the form of an hour is also equal to z over 60 hours. Okay, so your z could be anything. You would just put that z amount in minutes, but then to represent this in hours, you just divide this by 60. And again, this is where you see that 6 now pop up. Okay, so you know you have to deal with a 6, and you know there's going to be some cancellations of some sort, specifically from the 10 to the power of -3 and the 60. So what I will show you, and then what you can figure out from there, is to get my, whoops, not the distance, to get my speed rather, which we know is, yeah, still in holiday mode, there we go. To get my speed is my distance, which is x times y times 10 to the power of -3 over my time, which is z on 60. Okay, this right here is the speed. It is not being simplified or tidied up. That you're required to do. Okay, and you will eventually get to the correct answer, assuming that your the processes that you use to simplify this is correct. But this is the approach of tackling question 14. A bit of a doozy, or one of those infamous questions. Hopefully it should shed some light to the approach of this. Best of luck with tackling the rest of this question, guys. Hopefully this makes sense. And I'll see you guys, if you do see this, I'll see you guys when you get back in, back to school, ready for 2022. With the weird unknowns of how the year's going to be. We'll get through it. Alright guys, best of luck. Talk to you guys soon.